Hello, we're Group 6, and we're with a blast from the past, the Vinci's Helicopter. I'm Michelle.
I'm Dion.
I'm Min.
I'm Rebecca.
Da Vinci's helicopter was supposed to be operated by man. They would turn the crank on the device, creating a torque on the large canopy in order for it to take flight. Unfortunately, even though the spiral of the canopy resembles that of helicopters we see today, the device was defective. That's why we're going to present to you a virtually static representation of Da Vinci's helicopter.
This is the overall diagram of our assembly. We took a bottom-up approach on our assembly. This highlighted region is the bottom portion of our assembly, and so this is where we started. We started with having the base set at default and then adding on top using dowels. So our first set of dowels were added to the base, and then supports were added on top. Another set of dowels were added on top of the supports, and then those were connected to the lower and inner platform. The inner platform is used to connect with the top part of the assembly. Within the base and the supports, there are several rings being used which are held together using dowels. Also, holders have been put in place so that there's some space between certain parts so they don't interfere with each other.
For this part of the assembly, it will also be at the bottom of the entire assembly. So we'll start with the turn holder being in the center hole of the base. Then the fifth dowel will go for the turn holder and the base. Then you have the small gear going for the fifth dowel. Then 8 dowels going for the gear. And on top of those dowels, there will be another small gear.
For our top assembly, the top dowel is going to be inserted into the drum hole center. 4 dowels is going to be inserted into the drum holes. The ring is going to be on top of the inner platform. The 3 mast support is going to be inserted into the ring holes. The mast collar is going to be being supported by the mast support. The mast is going to be centered inside the mast collar. And there's going to be 7 mast dowels is going to be inserted into the mast hole surrounded. And the canopy rim is going to be on top of the mast dowel. And lastly, the canopy is going to be on top of the canopy rim.
There is only one base. The base is the most bottom feature of this device. It holds in place the dowels that encase the crank and it can only fit 2 types of dowels with 2 different diameters. It is important that the tolerances prevent slanting of the holes because they could potentially ruin the angles of the dowels and prevent them from entering the holes of the platform. Secondly, it is important that at least one face of the platform is flat so that it can be placed on another flat surface without the worry of wobbling. The most amount of material is preserved. The dowels. There are several dowels with only a difference in length and diameter. The dowels are placed into the holes of the other features and serve as the support and connection with other features. They are like the glue or extensions of the parts that they are placed into. The tolerances ensure that there is not too much bending in the material, and the flat sides of the dowels need to be as straight as possible to lessen unevenness in their support. The most amount of material is preserved.
Support A. For the function of the support A serves as a support for the dowel and can be represented as a crank handle. It connects the lower part of the assembly. In the assembly, the dowel are placed into the support A with the same size hole. As this crank will create enough torque to make the top assembly to rotate. For the goal is to create an engineering drawing of the support A, and in order to control the overall length, width, height. In addition to make sure that the surface is flat and to prevent the surface from being uneven. Support B and C. 2 with holes and 2 without holes. For the function, the support B and C serve as a support for the lower platform and top part of the assembly. In the assembly, the support B and C is on top of the base, equally spaced out, which can be 4 of them. A dowel is inserted through the support, only the 2 with holes. The goal is to create an engineering drawing of the support B and C and to control the overall length, width, height, and the size of the hole. Furthermore, to make sure that the surface is being flat and to prevent it from being uneven.
The function of the holder is to separate certain parts from interfering with each other. The holder is assembled onto the supports by aligning the center hole of the holder and the hole of the support. A dowel is placed through the middle to ensure the position. The goal of the engineering drawing is to control the position of the center hole. The ring functions as a part which connects and supports the top part to the bottom part. It also is used to hold several dowels in position. The rings are assembled by inserting dowels through the center hole and the outer holes to the dowels which are connected to the support. The goal of the engineering drawing here is to control the position of the center hole and the outer holes.
The mass support. The function of the mass support is supposed to be placed into the three holes of the ring A. Also, the mouth part of the mass support is supposed to hold the mass tower in order to help aid the mass tower's function. In the assembly, each of the mass support will be placed into the hole of ring A. Then each of the mouth part of the support will hold the mass tower, as seen below. The goal of the drawing is to have the bottom of the support to fit into each hole of the ring A. Another goal is to help the mouth part of the support to hold the mass tower type A. The mass tower. The function of the mass tower is to hold the mass to a specific area. The mass tower also contains three cuts so that the mass support can be inserted into it. In the assembly, the mass will be placed into the center of the mass tower. The mass tower is being supported by three mass support, each placed into three cuts of the mass tower. The goal of the mass tower is to hold the mass into place and to be aided by the mass support.
The function of the drum is to support the dowel and the mast. The drum is assembled by centering the center hole of the drum and with ring B together and aligning it by having a dowel inserted through the middle. The goal of the engineering drawing here is to control the position of the four side holes and of the center of the cylinder.
The mast. The function of the mast is like a helical rotor. It's allowed the top part to be supported and it's connected to the bottom. The assembly is going to be the mast is centered in the drum hole and the lower part of the assembly. Dowels and mast collar are assembled into the mast. The goal is to create an engineering drawing of the mast and so that we can control the overall length and the size of the hole. Furthermore, in order to make sure that the axis line up correctly and to prevent from being oscillated.
The canopy rim. The function of the canopy rim is to be the support for the canopy and to be held by the dowels that connects to the mast, as seen in the picture. In the assembly, it will be placed on top of the dowels that surrounds the mast, and the canopy will be placed on the rim. The goal is to create an engineered drawing of the canopy rim, and to show that the sweep is based on the equation, and the rectangle will go through the sweep function.
Lastly, the canopy. The function of the canopy is like an airplane wing. It's being supported by the canopy rim and the dowels. It connects along with the canopy rim to create an upward lift. In the assembly, the canopy is on top of the canopy rim and the dowels, which connects to the mast. Lastly, the goal is to create an engineering drawing of the canopy and to show the equation. Also, to show the radius, the starting point and the ending point of the canopy.
Thank you for listening. I hope you've learned a little bit about Da Vinci's device, and that concludes our presentation.